Hi there, this is Dr. Everybody with Project 4. In this project, we'll be writing some functions. And our mirror tests, we'll be able to test these functions individually. So each time you write a function, you can get it tested immediately. And what you want to do with the functions is write them and test them one at a time, and then do the main part of the program last. And we give you a template to start that with. And so having a main program in there is helpful in terms of testing. It's fine if that main program is empty, but we will want that. We'll want that there. So what I'm going to do is, let's take a look at what we have here, and we have some Taylor expansions of some things like here we show you tangent, although we actually don't use tangent. There's pi, and we ask you to do sine and cosine and so on. And so what I did, what I thought I'd do is do something very similar. But before I do that, let me point out two things. Notice that each of these will say that we're going to keep going until the absolute value of the next term is less than our epsilon. And it's nice to make that a constant. And that will not be included in the sum. So that ends up being important. Okay. So with that, what I did is I looked up Taylor series in Wikipedia, and they happen to have the e to the x as one of the examples that they had there. So I thought I'd write a function e to the x. Now let's take so they give us the summation of each term, okay, and we can see we've got an x, right, and we see we've got an n, and we use that n again down here, and we've got a factorial in there. And when you look at this, you can see that the term starts at 1, and you could do this by writing that out, and I suggest that with the project you actually by hand write this out, just so that you get a sense of what's going on. And and then also we need somehow to capture a sum. I'll call it our sum e here. So we do need each. We call each of these a term. And so given that, what would my what will this look like? So one thing that we can do is we can take a look at this as pseudocode. All right, so we're going to need a function, some e to the, and in this case we're doing an e to the x. All right, and I mentioned some things in there, like we're going to need a term, and we're going to need a sum. I called it sum e, and we're going to need an n. All right, we know all these things by looking at the equation. Those are the different pieces that I'm going to have there. And then I need a loop. Now we don't know how many times we're going to do a loop, so this will clearly be a while loop with some Boolean in there. And this Boolean is going to have something to do with the epsilon that I have. And we also see in there that I need an absolute value. All right, so there's a lot of things in there. And with each of my terms, I can see that I'm going to need a factorial. So that means somewhere up here, I'm going to import math so I can use the math factorial. And then what are we going to do? Well, certainly my term's going to start with a 1. My sum will start with a 0, and my n, well, depending on how we do this, it might start with a 0 or maybe a 1. All right. And then what will my terms look like? Well, I will, so I need the absolute value in there. Oh, and my term is going to be part of my this Boolean that I have there. So I have to get all that stuff into my Boolean. We could talk about that in a moment, how that might look. And then I'm going to want to do my sum. And in this case, we add my term onto the sum. And then, what does my term look like? Well, my term is going to be this thing, x to the n over n factorial. Okay, and notice I'm going to have my math.factorial. I'm going to have to look that up and see what that actually looks like. It'll be factorial of something, and then every time through the loop, I better, we can see my n's go from 0, 1, 2, 3, 4, 5. So certainly my n's are going to have to increase every time. And then at the end of this thing, I'm going to have to return my sum. Now, that was a little more detailed than we'd like to do. I actually wrote too much code down here. But we get a little bit of an idea of what this program might look like. And so given that outline, let's actually code it up. Okay, so we certainly need to have my import math, and we're going to define my function here. And so term is 1, sum is going to start at 0, and maybe it's going to equal 0, maybe not. And now I need a Boolean expression in here. And what do we have? Well, the instructions say that we're going to go up until my term, and this would be the absolute value of my term, is less than some epsilon. And I guess we better define epsilon. And we provide that in the project description. I think it's something like that, some very small number, right? So while my absolute value of my term is less than epsilon, so remember in this case we, as soon as it isn't small, actually, what do we say here about my epsilon? We say until it's very small. Okay, and so we want to keep going while it's bigger. Right. And then what do I do? Well, I'm going to add my term on here. Right, because we say, all right, we keep going while it's small, and as soon as it's not small, then we'll stop. And then I need to calculate. Let me bring up my thing here. So, and here we go. I need to say, so what's my term? My term is the x to the n over n factorial. So we take my x to the n and we divide it by the factorial of n, and then we need to increment n, and then we need to return the sum. Okay, so let's see, we got a warning here. It's a sign, okay, that disappeared. We can save this, and I haven't built we don't have a mirror test for E, so I better do that myself. So we'll have my, I'll call it my E is, we just call that, I guess I need a value for X here. So let's go, let's actually input an X. So I have something to work with. I usually like to have a space there. So now I calculate the X, and so my E value will be my E, and then compare it with the actual, which is the math.e of X. Okay, and we can now give this thing a try. All right, and if I put in an X of 1, it says, oh, float object is not callable. And we have it here. So I forgot that if I look at math, it turns out that E is actually a constant. So I did this wrong. This is, we're calculating E to the X. There, that's better. Okay, so now let's put a 1 in there, and we see, okay, so so E to the 1, that's E as we would expect it to be, right? And we can see that, okay, oops, my value is off, and why is it off? Well, let's actually trace this. So I start with my, we want my first value to be 1. Okay, so my term is 1, and then we add that in there. That's good. Okay, so what happens with the next one? The next one ought to be X. So n was 0, and so now let's look at these. There was that one, and then so here's this one, and so I've got n is 0. But I want that exponent to be 1. So this guy here looks very suspicious. Remember up here we said, maybe we want a 0, maybe we want a 1. Looks to me like we want a 1 there. All right, so let's fix that up. And now let's run this thing with a 1 there. Now we've got these a little better. And notice that because my approximation, so the actual E, if you look at it, it does differ by some digits in the middle, which is okay because we're doing we're not going out to infinity. We're actually stopping at epsilon. I can try this for another value and of 2, and again, we see that for the first few digits we're okay, and then we kind of fall apart, which is fine. That's we're expecting that, and in fact, in your main program, you're going to be doing just this kind of thing. So what have I done here? I have I've taken an expression here. I wrote out the expansion. I wrote, jotted some notes on some code, working that out, and then I programmed up the function, and I put a little something in there to test. We actually have tests on Mirror for you. So hopefully this gives you a little bit of an idea of how to get started and good luck.